So back when you were in Algebra 1 and Algebra 2, you should have learned a lot of these functions. Of course, the linear and the equation is right here, written with a y, and then I write the equation here with an f of x. Okay, so this is called function notation over here. This is just your regular standard notation over here. And that's the most basic line that anyone could ever make. It's just y equals x for diagonal lines. Okay, down here on the graph, I also tell you the domain and range. Domain for any line is script R and range is script R. What's domain and range stand for?
It's like your x values.
Right. The domain is a list of all x values that could show up in this function, and then the range is a list of all the y values. So you can see on a line, it goes forever up, forever down, forever left, forever right. If that's the case, then you say script R for domain and range. Does that make sense?
Yes.
Okay. So that's a line. The next one is the quadratic function, which makes a parabola when graphed. Now, we're going to extend this a little bit more. You typically have just done it in terms of y equals x squared. In this chapter, you're going to also do x to the fourth, x to the sixth, x to the eighth. Anytime you have an even power, it makes a parabola. Okay? So it just makes a little wider at the bottom the higher the power goes. Okay? If the power becomes high, the parabola flattens out down here at the bottom. Okay? Everybody okay with that? Yeah. So it's now not just an x squared. This picture represents an x to the fourth, an x to the sixth, anything that's even. Domain, does it go forever left and forever right?
No.
It does not? You don't think it'll go forever like this?
Oh, yes.
It does, and forever left as well, so therefore the domain is script R. When you look at the range, though, the graph does go forever up, but it does not go forever down. So therefore your range is going to be restricted. This picture only exists from 0 up. Does that make sense?
Yes.
Okay, so your range is from 0 to infinity. Y is greater than or equal to 0. Does that make sense?
Yes.
Okay, so on every picture I've got the domain and range listed for you. Ignore the even and odd for right now. We'll get to that eventually. All right, this is the cubic function, y equals x cubed, or x to the odd power. If it's a fifth power, seventh power, ninth power, the higher the power gets, the more it will flatten out right here at this turning point. Okay? All right, so that's the cubic. Notice right below the, right here of the square root and here of the cube root. What is the square root, the inverse of? Of the squared, right? So a parabola, the inverse of the parabola is the square root. And if you notice, basically what you're seeing there is you're seeing half of a parabola. If I drew in the other half, it would look like that. But I can't do that because then it wouldn't be a function. Anybody remember what it requires to be a function?
The vertical line.
Vertical line test. If you can draw a vertical line and hit 2 points, it's not a function. So that's why they only give you the positive side of the square root function. Okay, the cube root function is the inverse of the cubic function. All right, so inverse means you just switch signs. So on a cubic curve, if you plug a 2 into a cubic, what do you get? 2,8, right? So the point 2,8 is on this graph. If you invert that, it's on this graph. So 8,2 would be on this graph. You go over 8 and up 2, that point would be on this graph. In an inverse, you just switch x's and y's. Okay, here's the absolute value function. It makes the shape of a V. It works very much like the parabola. These two are kind of in the same family as far as domain and range is concerned. Okay, reciprocal function, y equals 1 over x, or f of x equals 1 over x to the odd power. So in Algebra 2, you probably only messed with y equals 1 over x. And here, you'll have y equals 1 over x to the third, 1 over the x to the fifth. 1 over x to the odd power always looks like these. Okay? All right, in this one, if you have an even power in the denominator, y equals 1 over x squared, that makes what I call, and that's my name, you won't ever see that in a textbook, I call it the volcano function because it kind of looks like a volcano. Okay? If you graph it. And what about domain on these two? If you scan these graphs from the left to the right, you can see every number on the x-axis except for what?
0.
Yeah, at 0 you have an asymptote. This graph does not exist at 0, right? So that means your domain cannot be 0. So I think that's what I put here is x cannot be 0 just for shortcut notation. Okay? to write it as quickly as possible. Your y value is the same way. Y can be anything you want on this one. It just can't be 0 because you have a horizontal asymptote right there as well. This one, the graph completely exists above the x-axis, so I'm going from 0 to infinity, not including 0. And this function right here may be a new one for you. Did you guys study the step function at all last year? Okay, so that'll be a new one that you'll see in this chapter. It's called the step function, and you can see why, right? Looks like a set of steps. It's also known as the greatest integer function, all right? And it uses these little bars. It looks like a bracket with a line through it, all right? A bracket with a little line down through it. And so the way the greatest integer function works, I've actually got some points over here. If you plug the number 2.1 into the greatest integer, it means give me the greatest integer below this number. So what's the greatest integer below 2.1? 2. What's the greatest integer below 2.5? What's the greatest integer below 2.9? 2. Now, if you put just a integer in there, it will equal itself. It's the greatest integer below or equal to the number. Okay? So integers can't be decimals. So you're never, ever going to get a y value out of these that are a decimal. Does that make sense? The greatest integer function only returns integers. And so you can see my points are all 2 point something. So if I go over here to the 2's, between 2 and 3, every input between 2 and 3 is going to give me an output of 2. Okay? And so that's what makes the step. And its domain is script R, but its range, what do you think that Z right there means for range? Okay, that Z, it's the set of integers. Okay? Your y values will never, ever be a decimal. It will only be an integer. All positive, negative numbers, and 0. But no decimals. So that's what that Z means right there. It's the set of integers. Everybody good with that? And so we will deal with all 9 of those in this chapter. In the next, when we get to chapter, I believe, 7, we get to the exponential and the logarithmic. So they're already on there for reference, but we'll come back and reference those when we get to chapter 7. Okay? But for this chapter, you'll see a lot of these 9 functions. All right, everybody okay with that? Okay, now you will not be allowed to use this on the test because you can't use it on the ACT. You need to know these for the ACT, right? Okay, so that being said, let's look at the back of that sheet. Another thing you would have learned is how to shift a function left, right, up, down, flip it over, and so on. So if you look at this side, that's the rules for flipping, shifting left, right, up, down. So this is called the power function. So if you look at the power function, notice it's got every shift you could possibly have with an in power. This is what a square root looks like, or a cube root. This is what a reciprocal or volcano will look like with all your shifts. A step function, an exponential function, a logarithmic function. We'll do trig functions next semester. But if you look inside, at the very end, what do I have there? What letter is that?
K.
K. Now go down to the bottom and tell me what K does.
Vertical translation.
So everybody look at the very bottom of your page. I don't think it's showing up on mine, but if you look at the very bottom, what does it say that K will do?
Indicates a vertical translation.
Okay, well, what's a vertical translation?
Moving up.
Okay, so when you have a K number on the end, it shifts the graph up and down. What does the H on the inside do? Left or right. And what do we need to know about horizontal translations in this little negative right here? Always the opposite of what you think. The plus sign means, hey, it's going to be what you think it is. A positive number will mean shift up. But when you have a minus there, that means do the opposite of what it says, right? So it's going to go in the opposite direction, left, right, of what you think it would go. Okay, the other thing you probably studied in Algebra 2 was a negative in the front. What did a negative in the very front do? It flips it over the x-axis. So if you look down at the bottom, what does it say about a negative a value? It is an x-axis reflection. Okay? What does the a itself do? So that's shown right here and here. If the absolute value of a is greater than 1, This indicates a vertical stretch, so it's going to stretch it. Okay? If the absolute value of A is between 0 and 1, what does that do?
Indicates a vertical compression.
So it's going to do this to it if the A value is between 0 and 1. Okay? Compress it. Now, the B's, you will hardly ever deal with a B in this class. You will in trig. But B is a horizontal stretch or compression, and they work the opposite of the A's. But you're probably not going to run into we run into it just a little bit on the step function, but I'll explain that when we get there. So you're not going to have to worry a whole lot about having a B or a negative B. A negative B flips over the y-axis instead of the x-axis, okay? So the main thing you need to remember, up and down, the H is left and right, the negative on the front flips it upside down, and an A value will either compress it or stretch it vertically, okay? And there's what it looks like on all. The reciprocal is the one everybody kind of struggles seeing. A reciprocal, your up-down number's out here, and your left-right number is inside here, okay? A reciprocal and a volcano. All right, so that being said, let's go on to our packet. And ignore this for right now. That's flashcards I'm going to give you later. Okay, so 4.0 vocabulary. So and this is all review from Algebra 2 and Algebra 1, a relation. What is a relation? A set of ordered pairs. Okay, what's that mean?
It's like that thing right there.
So these things down here are all sets of ordered pairs. Okay, so right down here, see how it says circle the relations? That means these are all relations, sets of ordered pairs. So this oval-looking thing down here, the points on the oval are a set. Over here is, what's this thing?
That's a line or something.
What's the equation for? It's slope-intercept form, but what does that mean? What does it make when you graph it?
A line.
A line, right? So every point on this line makes up a set. So this line is a relation, a set of ordered pairs. So these are all just different examples. These are all sets of ordered pairs. Okay, so that's what a relation is. Down here, there's a bunch of examples. What's a function?
A relation where no 2 points can ever have the same value.
A relation. So what's a relation? Set of ordered pairs. A function is a set of ordered pairs where no 2 points can ever have the same x value. And that's what the vertical line test does for you, because if you have 2 points with the same x value, then you won't be able to draw a vertical line down through it without hitting both of them, okay? So, what's a function?
Set of ordered pairs.
Nope, that's a relation.
Relation of ordered pairs
Oh my God.
No 2 points have the same x value. No 2 points. It says, note, when a graph is given, use the vertical line test. Okay, domain and range, we already talked about those a little bit. So now we're going to look down here at all these relations, and we're going to determine which ones of them are functions. Okay, so let me scroll so we can see that a little bit better. Okay, so out of all these, we are going to circle the ones that are functions. So remember, in order to be a function, x cannot repeat itself. So look at this set. Does x repeat itself?
Yes.
It does. The 2 5s repeat itself, so it is not a function. Okay, so not a function. You can write no if you want. We're going to circle the ones that are. But anytime on this lesson that they ask you if something's a function or not, they'll say, okay, if it's not a function, prove it's not a function. Well, you're going to do that with these 2 points right here. It will make you give 2 points to show that it's not a function. So you have to give 2 points that have the same x value to prove it's not a function. Okay? Okay, how about this one right here? Yes or no? Is it a function? Why not?
It's 3 or negative 3.
Okay, so how would you prove that this is not a function?
Tell them negative 3 and 7.
You would give those 2 points, right? Okay, what about this one right here? Is it a function?
Yes.
You can draw a vertical line down through that thing anywhere, and the x's will never repeat. So we're going to circle that. Yes, it's a function. Okay? How about this thing right here?
Yes.
That's a line. Clearly a diagonal line. You can always draw a vertical line through a diagonal and never hit more than 1 point. Okay, how about the oval down here?
No.
Okay, that's not going to be a function because the vertical line test, if you draw right through there or anywhere else, you're going to hit 2 points. So if it says prove it, you're going to name that point and that point, which would be what? -4, 1 and -4, 7. So right there, we're proving it's not a function by giving it 2 points that do have the same x value. Okay? And then the last one, this is called a mapping. And on a mapping, you use these arrows. It says 2 goes with 4, but 2 also goes with -5. So if you were to write this as an ordered pair, you would have the 2 going with a 4, and the 2 also going with the -5, and that right there shows you that it's not a function. So that picture consists of these 3 ordered pairs. On these 2, x repeats itself, so no, it's not a function because of these 2 points right here. Okay? Does that make sense? All right. All right, so every page from here on out is one example. All right? So this page is all one example, and it will be some sort of set of ordered pairs. So this time, it's listed in what we call set notation. This is set notation, and I want to provide a graph of this set. So how would I graph that set? Okay, well, 2, 2 is right here. Just draw where all those points are. My pen does not like to make little circles. It thinks I'm trying to do something else. So there's 2, 2. 2, -1, -5, -1, and -4, -1. So there's my 4 dots. Okay? And Jada says it's not a function. Why'd she say that? Oh, those 2, I could draw a vertical line right down through here, and I'd hit 2 points, right? So is it a function? No. So you circle no, and then you list 2 points to prove it. Or if you want to just come over here and circle the 2 points. The 2 points that keep it from being a function are 2, 2, and 2, -1. Okay? That's why it's not a function. Everybody okay with that? Okay, now I need to list the domain and the range. What does domain look like on this thing? What is a domain, by the way? So list of all x values. What are my x values? 2, -5, and -4, and I'm going to put set brackets around that. That's a set of numbers. The domain is a set. So those of you that do mathletes, and there's that test called set theory. You see a lot of notation like this in set theory. Okay? All right, range. What's my range?
2, -1.
All the y values. My y values are 2, -1, and that's it, right? You don't have to write it. If it occurs more than once, you don't have to write it more than once. So there's the items in my domain. There's the items in my range. And this is called a finite set. Finite is the opposite of infinite, right? Infinite means a set that has endless points. A finite set has a set number of points. How many points are in this set? 1, 2, 3, 4. Okay? How many elements are in this set? 3. How many are in this set? 2. Okay? Those are kinds of questions you would see on a set theory test.
Why do you use that type of practice?
That's just the common practice in mathematics for a set. It's called a set bracket. And they are kind of a pain to make. And when I was your age, I hated them. I just made little squiggle marks, and that's fine to do. You get better at them with... Yeah, I've been making them for a lot of years. So, all right. So next page, I believe we're ready for.
What about the equation part? Have an X through it. Never mind.
Yeah, I have an X through there because
what that was.
there's no way to write an equation for those points. They don't have any pattern between them, like a line would to show that. All right, second page, I also have an X through the equation part. And this time it's basically backwards. This time I'm giving you the 4 points on the graph. Now you have to write it as a set. Okay, so what points are in that set?
4, 0.
So I make my set bracket.
-1.
4, 0. What'd you say? Negative
3, negative 1.
negative 3, negative 1. Really, I should have commas in.
5.
Negative 7, 5.
It's 4. Negative 7, 4.
Negative 7, 4.
Yeah.
I'm just relying on you guys.
Negative 7, negative 4.
Negative 7, negative 4. Everybody agree that those are the 4 points?
Yeah,
Everybody okay with that? Okay, so is it a function, yes or no?
oh my gosh, no.
Okay, not a function because I could draw a vertical line right down through here. The points that prove that it's not a function are these two right here. Okay, so if you want to write those up here, you can. That's what you'll have to type in to prove that it's not a function.
You have to put set brackets around those two.
No, they give you, you don't, no, not these two.
Okay.
It'll just have 2 blanks for points, okay?
Awesome.
And even if they were requiring a set, I think they would give you the set bracket, and you would just put the stuff in between. Okay, so domain, what's my domain? 4, negative 3, negative 7.
Oh, wait.
Yeah, Josie, pay attention.
And my range?
I was making sure.
0, negative 1, 4.
So domain is x values, yeah?
Yes.
Domain is x values, range is your y values. Okay? Everybody good with that?
Yeah. All
Not. I see plenty of X values.
Okay, once again, now my equation is still marked out, so I don't have to worry about that, and so is my set of ordered pairs. So this time I'm not going to use my set notation because this is no longer a finite set. This is an infinite. Okay, this is an infinite set here. There's an endless number of points on the edge of this rectangle. We're not including the ones on the inside, just the one by the dark lines. Okay, all of those points make up this rectangle, and I want to say, is it a function or not? No, because, and there's a lot of things, a lot of different points you could give here to prove that. No, it's not a function. So I'm going to choose this point right here and this point right here to show that it's not a function. You could show one in the middle as well. Any 2 points lined up on top of each other. So that's what, 2, negative 1? 2, negative 1, and 2 what? I mean, I have a lot of choices. I could pick any of these over here, right?
Negative
2, negative 2, 2, negative 3. I can go all the way down to this one, 2, negative something, right? So we'll just say 2, negative 3. Okay? But the iPad is programmed to know that it will take all those. Okay? Everybody okay with it so far?
Yeah.
Not a function, fails the vertical line test. Okay, domain and range. So this rectangle, this relation, has a domain. Every point, if you were to write every point on this rectangle, all the x values would be contained between what 2 numbers?
2 and
So look at your x-axis.
2 and 5.
Okay, that rectangle completely exists between 2 and 5. Does everybody see that? Here's 2 on the x-axis, here's 5. That picture completely exists between those 2 numbers. Does that make sense? So your domain starts at 2, goes to 5, includes both numbers. So interval notation. If you were doing math relays and you had to do algebraic notation, that would look like this. In between, right? Algebraic notation, which is what they ask you to do on equations and inequalities in Mathletes. Interval notation, which is what they'll probably want here.
So do you not put the bracket like the set bracket?
You do not need the set bracket. I'm using interval notation, not set notation, okay? You really couldn't use set notation because it's an infinite set. Because, you would have to list out 2.1, 2.2, 2.3, 2.33, 2.39, you know what I mean? All of those are included, and when you do set notation, it's a lot easier to have a finite set, okay? Now, if you were using set notation, in college, you do use that, and it would look something like this. So everybody listen up. This is some new notation, but we do encounter this a little bit in Chapter 8. But it's the set of all x's. This means such that x comes in between 2 and 5. So that's what that would look like if you had to use set notation. This means when you see set brackets, you say the set of all x's. This line means such that. the set of all x's such that x lies in between 2 and 5, including those numbers, okay? You don't have to do that in this chapter at all. Just exposure there, okay? Joseph, is that a question?
Yeah. How do you want us to do it?
It will say give interval notation, okay? So on this lesson, you'd give it like this. At Mathletes, you give it like this, okay? And you're going to get to eventually classes where you use this notation if you take more math classes. Range. Okay, where does that rectangle exist on the y-axis? Looks like between here and here. -1, -7. Everybody with me there? Okay, -1, -7. So my range is from -1 to 7. Make sure you put them from left to right or bottom to top. So algebraically, that looks like this. So that's the notation you'd use at Mathletes. In a calculus class, it would be the set of all y values such that y comes in between -1 and 7. Okay? And in chapter 8, we get to this notation a little bit.
Wouldn't it be -1 and -7?
Oh, you are right. It should be a -7. Thank you. Put a negative in all those sevens. And that means I have it backwards, right? Darn it. All that is now wrong.
Do you go from like,
Because why? Why is that wrong?
Because -7.
-7 is smaller than -1, right? So you got to write it like that.
will they count you wrong for that?
Yes, they
Oh,
will.
Man.
In interval notation, you always have to go from smallest to largest. Or it's the set of all y's such that y comes in between -7 and -1. Okay? This is the only one they require for this lesson. Everybody okay with that?
Yes.
Okay, let's move on to the next one.
Oh, what a cute little one.
Okay. So anybody know from geometry what the proper term for that would be? It's not a line. It's not a it's a line segment. What's the difference between a line and a line segment?
A segment doesn't
has
continue,
ending
it's only between.
A segment has endpoints. It does not go on forever. Okay, so that's going to make my domain and range specifically between two numbers. So first of all, is it going to pass the vertical line test?
Yes.
Yeah, this one actually passes the vertical line test. We do have a function here. Okay, good. And equation. Can I write an equation for that line?
Yes.
Sure I can, because I have 2 points and I can calculate the slope, right? What is my slope?
2/5?
Yeah.
Up 2/5, everybody agree with that? So if I'm going to write the equation, my slope is 2/5. And name me one of those points.
-2, -5.
Everybody agree, -2, -5? Looks good, okay. So the point -2, -5. So if I want to write an equation, I would have to use point slope form, right? So, good, we're reviewing something that you're going to use on the test. Y plus 5 is equal to 2/5 x plus 2. Okay, now we're just going to leave it like that because it just asked for an equation, right? Okay, I could easily put that in slope-intercept form or standard form by multiplying by 5. Okay? Yep.
Well, I don't know, I'm just confused, because when I know why you're writing it like that, like why you're leaving it like that.
Okay.
Why do you do y plus 5 and x plus 2? Because when I did, I just plug in my x and
Okay, so I'm doing a different method than you. I'm using this formula right here. Point slope form. You're going directly from slope-intercept form.
Yeah.
Okay?
Got it.
And the way you do it's fine. There's nothing wrong with that. But I do like to expose you to point slope form because it does show up on the ACT, calculus, all that stuff. Okay?
Okay, thank you.
All right, everybody okay with that? Okay, so I'm going to skip the set of ordered pairs on this one. Okay? And now let's do domain and range. Okay? My domain, this is a specific. It does not go on forever, does it? So it's not script R like most lines would be. Where does that thing exist on the x-axis? And I think I even have it marked for you up here.
-7 and -2.
So -7 and -2 on the x-axis is where that picture exists. So from -7 to -2, including those numbers. And now where does it exist on the y-axis? Okay, -7 to -5. Always want the lower number to be listed first. Okay, does that make sense?
Yes.
Everybody good with that one? It is, but you'll be glad we did it. It's very helpful for the whole chapter.
Will we finish today?
I'm not sure. Probably not. What do we get out of here? 47? Yeah, we're probably not going to finish this today. Okay, which is good. That means you don't have homework to worry about yet, right? Okay, so on this one's a diagonal line, but it's an infinite line. It goes forever, up, down, left, right. So is it going to pass the vertical line test?
Yes.
Yep. Okay, I need to write its equation. Y equals negative x, she says. Is she right? Mine will not switch to the pen here for some reason. It is. There we go. Finally went. Okay, so on this line right here, if you look at it goes through the origin, so its y-intercept is 0, and it has a slope of down 1 over 1. Am I right?
Yes.
Okay, so if you're using y equals mx plus b, that means your b is a 0, and your slope is a 1. And it's a -1 because it's going downhill. Down 1, right 1. So the shortcut way to write that is y equals negative x. That's as simplified as you can write it. Okay? Does that make sense?
Yes.
Now, I'm going to take it a step farther here. You'll be dealing with functions a lot in this chapter. So to write this in function notation, instead of saying y equals, you would say f of x equals negative x. Okay? So whenever you see an f of x, don't let it confuse you. It does not mean f times x. It's a new notation for y. Okay? So it means the same thing as having a y equals. Okay? Yeah, that's just, if it confuses you, just replace it with a y. Okay? But you'll see it like this a lot. Okay? All right, so we said yes, it's a function. And my domain and my range. Okay, script R. Forever left, forever right, forever up, forever down. All diagonal lines have a domain and range of script R, providing it goes on forever. Okay? Now let's talk a little bit about this one right here, set of ordered pairs. This still goes up in this box. Okay? And the set of ordered pairs, once again, this isn't something they're going to ask you, but I am exposing you to it because you get to it in chapter 8. So this is what this one would look like in set notation. It would be the set of all points x comma y such that y is equal to negative x. That's what it would look like in set notation. It means the set of all points x comma y such that y always equals the opposite of x. So in other words, this point right here is 1, -1. So 1, -1, y is always equal to the opposite of x. Okay? That's what that means. And we're going to stop there for today.